Hello everyone, welcome to Algo Arena. Here on this channel, I discuss coding problems and their solution. And today I'm going to discuss the solution of Leetcode Problem 1695, maximum erasure value. You are given an array of positive integer nums and want to erase a subarray containing unique elements. The score you get by erasing the subarray is equal to the sum of its elements. Return the maximum score you can get by erasing exactly one subarray. They have given the definition of the subarray here. Okay, so in this question what we have to do exactly is select one subarray such that all the elements in this subarray will be unique, and the sum of all those elements will be the maximum. Okay, so like in this example, uh, this particular subarray has all the four unique elements and its sum is 17. In the second example, they have selected this particular subarray, or you can say this particular subarray, where all the elements in that subarrays are unique, and they give the maximum score of 8. So we have to return this maximum score of 8. If you see the constraints that nums of length is less than equal to 10 to the power 5, and all the values in the array are in the range of 1 and 10 to the power 4. So we are expect the expected time complexity will be n log n and below. So what we can do here is use the two pointers approach with sliding window to find out the answer. I will explain the approach and solution on the whiteboard. Here, if you see that I have taken one map to store the frequency of all the values in the current window, since we are dealing with the uh, duplicates, and we have to track only the unique elements in the given subarray, and the sum will be initially will keep it 0, and also the maximum sum will be 0. The sum will contain the summation of all the elements in the current window, and maximum sum is basically the answer that we will return in the end. So as I said, we'll keep two pointers here. So our left pointer will be like here, and our pointer, let's say, here. So what first what we'll do, we'll update the right pointer's value in our map. So the value is 5 and the frequency is 1. Since the frequency is 1, we will update it in add it in our sum. So this will be 5, and maximum sum will again be 5. And now what we'll do, we'll update our pointer to here. Now we'll update this value in our map. So 2 and frequency will be 1. Since this is also a unique element, we'll add it in our answer. The sum will become 7, and maximum sum also will become 7. Now let's increment our R pointer to here. Okay, so the value will be 1 and frequency will be 1. And since again this is the unique element, we'll update again our answer to 8, and our maximum sum will be updated to 8. Now again we'll do, increment our R pointer. So our pointer will be here. So uh, the 2 has appeared twice here, so we'll update this in our map. Okay, so uh, the value will become 2. And if we keep incrementing our point, there is our pointer, and like getting the maximum, so there is no use, because since our 2 is appeared twice here, so to get only the unique elements, we'll have to trim it from the left side. So that's what I'm going to do here. So what I can do here is, first of all, update the like, since we are removing the left pointer, left element from here, so I will update it on map, like make it 0, since we are removing it in our from our current window, and my sum will become uh, 3. And I will not update the maximum sum because I have already have the maximum sum as 8. Now what I will do, I will increment the left pointer. So my left pointer will be here. Now I will decrement the uh, pointer here, so value frequency here, and again my sum will become 1, and I will not update it with the maximum sum, but I will update my left pointer to to the next index, that is here. Now if I see that uh, nums frequency of nums of r is 1, that means all the elements in the current window are unique. So now from now I can increment it again, like expand my window again. So I will, what I'll do, I will update it with 3, and maximum will be the 8 as it is. Then again I will update my R pointer here, and the frequency will be again 1, and again I will increment my sum, that is 8. Now again I will increment my right pointer here. If I again see that R has appeared twice, so I will increment here, and now from here on also I will have to trim it down from the left side. So what will happen is, I will decrement this 1 from here. I will this will become then 7, and I update my left pointer to here. Now again decrement, since our current the frequency of nums of r is again 2, so again we will have to update it in our from our, like trim it down from the left side. So this will be 1, this will be 5, and the maximum sum will be 8. Now again our left pointer will be updated from here. Okay, and now if we see that the nums of frequency of nums of r is again 1, so I can expand my current window from the right side. So what will happen is, I will include this 2 in my sum. This will be again 7. The maximum will be 8. Then again I will increment my, sorry. Then again I will increment my R pointer to here, and then R. Sorry, I think I forgot. No, I had forgotten to make. Sorry, it was 0, and now it will again become 1. Okay. So again I will include it in my answer. This will be again 8. Maximum will be on again 8. Now what will happen? I will again increment my R pointer. Like R pointer will be, then my new R pointer will be here. This I will update in my answer. Sorry, frequency. So frequency will be 2. So again I will have to trim it from the left side. So my frequency left frequency will be again become 5 frequency becomes 0. I will again decrement it from my answer. It will become uh, 3 and the maximum will be 8. Then I will update my left pointer again since the value frequency of nums of r is 2. Again in this here will go here, decrement the nums of L, it will be 1 and our answer will be again only, I will write it here 1 and maximum will be 8. Now and our left pointer will become uh, uh, left pointer will be updated to here. Now again if we see that frequency of nums of r is 1, so we can again expand our current window. So what will happen is first of all include this in our answer, so it will be 2 and the sum will be, sorry, this will be 3 not 2, this will be 3 and maximum sum will again be 8. So again I can increment my r pointer. Okay, so my r pointer will be here. I will increment my frequency here, this will be 1 and increment it in my include it in my answer, this will be again 8 and maximum is again 8. Since the current wind, and if we again increment our pointer will be out of bounds, like we will be out of bounds. So here we will end our uh, so here from here will be out of like exit, will exit from our loop and we can just return our maximum sum. So now let's discuss this in the Java code. Here I will keep n as nums dot length and I will take integer map instead of hash map because lookup time in our regular array is much faster than the hash map. Not much faster, but slightly it is more efficient. So I always prefer integer array over the hash map. And since the highest value that we can see is 10 to the power 4, so the size of this will be uh, 10,001. Okay, I will keep the max sum as 0. I will keep current sum as 0. I'll keep my left pointer as 0 and I will start from the right pointer 0, then r is less than n, r plus plus. So first of all what I said, increment like in update in our map, nums of r should be plus plus and then include it in our answer, nums of r. Now while L is less than R and nums of R is greater than 1, what we'll do, we'll update our map of nums of L minus minus, we'll decrement it, then we'll decrement also decrement our sum, nums of L and increment our L pointer here. And since the current window will have only the unique elements, we'll update our max sum with the maximum sum. Max of max sum and sum and we'll return the max sum. Yeah, so let's run it. Okay, so I think we have made some mistake. I will debug my code. Okay, so nums of L. So this is actually the map of nums of R. I think let's try to run it again. Okay, so test results have passed. Let's submit it. Yeah, and this is successfully submitted. Thank you for watching this video. Please like, share, and subscribe.